Hello everyone, I am Ria Josephine from Team EcoSpectra of St. Joseph's College of Engineering, and I am here today to present our idea for Hackathon 26 under problem statement PS05 Open Innovation Challenge. Our solution is called YuktiResearch AI. So, Yukti means logic, research is academic research, and AI stands for an artificial intelligence agent. Together, YuktiResearch AI represents logical, verified, and intelligent academic research automation. So, our problem statement revolves around academic and professional research. Today, conducting proper academic research is extremely time consuming. Students and researchers spend hours, sometimes even days, searching for papers, validating citations, and formatting references. And even when they use AI tools, there is a serious problem: hallucinated citations, unverified references, and non academic sources. This creates a huge trust issue. In academic research, even one fake citation can invalidate the entire paper. Beyond that, researchers today face information overload. There are thousands of papers available, but no efficient way to quickly identify what is credible and relevant. Most AI tools generate content that sounds confident, but they don't tell you where the information actually comes from. In many cases, the citations look real, but the DOI doesn't exist. The authors are wrong, or the paper cannot be traced. And formatting is another headache. Switching between IEEE, APA, MLA, or Harvard takes manual effort and constant corrections. So, researchers end up spending more time on searching, validating, and formatting, and much less time on actual thinking and innovation. That's the problem we wanted to solve. YuktiResearch AI is an autonomous AI system designed specifically for academic research. It generates structured, citation verified research reports in minutes. Importantly, it doesn't behave like a single chatbot, it works like a research team. Our system follows a planner to executor to publisher architecture. First, the planner agent understands the research topic and breaks it into logical subquestions. Then, multiple executor agents work in parallel collecting information from trusted academic sources like ArXiv, PubMed, and Semantic Scholar. Finally, the publisher agents synthesize only verified content into a proper academic structure. This avoids random answers and ensures logical flow relevance and citation integrity. In order to know more about the Yukti AI's feature, I have added our exclusive GitHub repo where we have mentioned the current features of YuktiResearch AI and the future implementation strategy as well. So, without further ado, let's move on to the tech stack and architecture of YuktiResearch AI. So, technically, the system is built using Python and Fast API with local LLMs via Ollama. We use WebSockets to provide real-time research progress updates. A content aggregation layer removes duplicates, filters low-quality sources, and ranks papers based on relevance and year. This ensures that the final report is clean, credible, and academically valid. One of the strongest aspects of YuktiResearch AI is DOI-based verification. In academic mode, the system blocks all non-academic sources. Only papers with valid DOIs or ArXiv IDs are allowed. So every citation in the final report is traceable and verifiable, completely eliminating citation and hallucination. Alright, let me quickly explain how YuktiResearch AI works behind the scenes. So first, here we have the user interaction layer. This is where everything starts. The user simply enters a research topic through the interface, and the research topic is further read by the research orchestrator. Once the query is submitted, it goes to the research orchestrator. Think of this as the manager of the system. It receives the query, keeps track of the research state, coordinates all the agents, and most importantly, prevents a redundant execution. So, why it matters in a sense, this avoids repeated work and keeps the system efficient and controlled even with multiple agents running. So next comes the planner agent. This agent doesn't search the internet, instead it thinks first. It breaks the research topic into clear sub-questions, defines the scope, and creates a structured research plan. This ensures that the output follows a logical academic flow. Then comes the parallel research agent. Now, this is where the real work happens. Based on the plan, multiple research agents run in parallel. Each agent has a specific role. One handles academic paper retrieval, one processes the document, one focuses on metadata and citation extraction, one handles web or contextual research when required. All of them work at the same time, not one after another. Why it matters? So, parallel execution makes the system fast while still being thorough and accurate. Then we have the content aggregator. Once the data is collected, everything flows into the content aggregator. So this layer removes duplicate sources, filters out low quality or irrelevant papers, ranks content based on relevance. What comes out is a clean, high quality research input. And we have the LLM processing layer. Now the clean research is passed to the LLM processing layer. Here we use local language models, not cloud APIs. This processing is chunk based, citation aware, and fully grounded in the verified sources. So next comes the publisher agent. This agent structures everything into a proper academic format: abstract, introduction, related works, methodology, result, and conclusion. It also applies an academic tone suitable for papers and reports. Finally, here we have the output and export layer. Once the report is generated, it goes to the output and export layer. Here, the report is rendered on the UI and can be exported as a PDF or Word document. This system also stores session history for future reference. Here, users can edit, submit, or reuse the output easily. Finally, we have the chat interaction layer where users can ask follow-up questions, but only within the context of the generated report. This layer is intentionally context limited to prevent hallucinations. Follow-ups stay grounded in verified research, not imagination. So one simple strong line flow is like we have user query, planner, parallel research agents, followed by aggregation. Then we have the verified LLM synthesis, then publishing agent, and exported academic output. So this architecture ensures that the system is logical, verifiable, transparent, and engineered, not just generated. Now let's see the feasibility and challenges of YuktiResearch AI. So YuktiResearch AI is built entirely using stable open source technologies. It can run on mid-range systems with around 16 GB RAM, and importantly, it does not depend on paid LLM APIs. The system is modular and scalable, which means individual agents can be improved or extended independently. Some challenges we identified include LLM hallucination risks, large report generation time, and maintaining paper credibility. These are mitigated using multi-source verification, DOI validation before citation, chunk-based processing, and smart catching mechanism. So coming to the impact and target users, YuktiResearch AI creates impact across multiple user groups. For students and researchers, it drastically reduces the time spent on literature surveys and citation management. For academic institutions, it promotes research integrity and improves the overall quality of submission. For policymakers and business analysts, it enables faster generation of well-researched, evidence-backed reports. Overall, it democratizes access to ethical, verifiable, and cost-effective research automation. So, coming to the components to be demonstrated and implementation plan, in our demonstration, the key components we focus on are like multi-agent research workflow, local LLM integration, academic source retrieval, DOI extraction, and valid logic. So, these components together validate the practical implementation of our idea. And so our implementation plan is, first we finalize agent orchestration and optimize report synthesis. Next we will improve the UI, export quality, and add research templates. Finally, we deploy a stable demo instance using local compute systems, open source libraries, and free academic APIs. This phased approach ensures that the solution is both feasible and scalable. So, the foundations of research AI and its references include it is inspired by establishing concepts such as retrieval augmented generation, reasoning and acting, plan and solve prompting, and multi agent AI systems. We also build prior research frameworks like GPT Researcher, Storm, and related academic literature from ArXiv and PubMed. This ensures that our solution is academically sound and technically validated. Coming on to the impact and value, YuktiResearch AI helps students, researchers, institutions, and analysts. It reduces research time, improves citation accuracy, encourages academic integrity, and democratizes access to quality research. So, to conclude, Yukti Research AI is not just another AI writing tool, it is an autonomous, privacy first, citation verified academic research assistant that brings logic, trust, and speed to academic research. Thank you for your time. We are excited to present Yukti Research AI under PS05 Open Innovation Challenge. We have also attached our complete project demo at the end of this video, showcasing the system, workflow, and final outputs in action. Thank you once again.